Hello everyone, this is Anniruddh studying in Sri Venkateswara College of Engineering. Today my subject is mathematics for CSE stream and my topic is image processing and calculus. Image processing is something which sounds very complex, while calculus is something which half of us don't understand. So it will be fun for me to attempt to explain you both of these concepts. So let's get started. What is image processing? Image processing refers to techniques to analyze or enhance or manipulate images. It is also used in color grading, computer vision, 3D, medical image. Oh yeah, and in medical image, we use it in X-rays, MRIs, as well as CAT scans or PT scans. Fun fact, for PAT scans and CT scans, we use gamma rays. Moving forward, what do you think is the role of calculus in something like image processing? So, as we all know, the basic definition of calculus, which is to simplify things, like reduce the number of things. So, like for example, like if we are going on a road at a speed of 20 km/h, we are measuring it in terms of kilometer per hour. But what if we want to measure it in macroseconds? Like how many meters are we going in seconds, or how many millimeters in a couple of milliseconds? So when we want to measure stuff like that time we use something known as calculus, and in calculus I mean differentiation. So using differentiation, we can find something like we can divide the very large quantity into much simpler objects. Apart from that, we have integration, which is the other half of calculus. In integration, we take very small things and we integrate it, like we add it to itself or something like that, so that we get a much bigger amount. Like we got it in kilometer per hour, but we want it in light years by light year. Oh yeah, fun fact, light years is a distance of time. Like we want it in light years by decades, something like that. So yeah, for that and all we use integration. So you might be thinking, for what will we use calculus in image processing? We use it to understand image gradients. And how do we understand image gradients? Using pixel intensities. So using intensities, we understand what, like we understand and we enhance the images. Apart from that, it also acts as a foundation for smooth operations like sharpening and edge detection. And now, what is gradient? Gradient represents the change of pixel intensity. You would have seen in Canva they have added a new feature called gradient backgrounds. So where one side is pretty dark and then the other side is pretty light. So gradient is like the intensity of pixels. It uses di by dx and dou I by dou y. So these both are partial differentiation with respect to x and y, because screen is a two-dimension plane. Apart from that, it also helps us detect edges and boundaries. Moving forward, convolution, a calculus-based tool. Convolution involves integrating an image with filter kernel. For example, using blurring, sharpening, and edge detection. All of these three features use convocation and have actually taken the courtesy to give you the formula. Please help yourself. And then smoothing images with calculus. So in smoothing images, we have something known as Gaussian blur. That's actually a pretty good kind of blur. I will refer something up there for you to check it out. Anyway, so it's basically linked to mathematically heat formulas. Besides that, it used to remove high frequency noises while preserving general structure. Moving forward, let's talk about edge detection techniques. I know I've used this word at least 3 times, edge detection. So let's actually find out what it is. It's a technique like Prewitt and Sobel, which uses canny edge detection, utilizing derivatives to identify edges. So basically, we use derivation to find the edges. So what is Fourier transformation in calculus? Fourier transformation in image processing breaks down the image into frequency components. Apart from that, calculus concepts like integration are centered to Fourier transform. Application includes noise compression, noise filtering, image frequency spectrum, and other things. Calculus and non-linear transformation. Non-linear transformation enhance certain image features. Example, logarithmic and power law functions. And its main applications is in low light images and dynamic range. Neutral network image and calculus. Deep learning with calculus in image processing. Calculus drive optimization in deep learning models. Gradient descents minimize role errors in tasks like classification. Key application super resolution, enhance image quality, style transformation, transforming images with artistic effects. And what is the importance of backpropagation? So using something known as chain rule in derivation, which is you derive the same thing multiple times. Well, students who study calculus would have understood the reference. Never mind, moving forward. What is the practical application? Practical application, as we have spoken earlier, medical imagery, automation vehicles, image compression, security, apart from that, video editing, and so much more. So much more as in even 3D comes in this, and it has a very huge scope. Anyway, in medical imagery, we use it for X-rays, gamma rays, MRIs, and all. In autonomous vehicles, we use it for multiple cameras. I know you would have seen Google's car. I may have put a picture over there during editing process. Ah, yeah, over there. So for automated vehicles, as well as it's used for image compression, we'll use it in data science. Apart from that, in security, like for measuring facial um, expressions. Apart from that, facial recognition, and then in video editing to match our like to match the photos, like the theme with the actual theme of the thing. Like if you're filming a horror movie, you wouldn't be using a happy theme. Movie fans would have understood it. Moving forward, conclusion. Calculus, the backbone of image processing. Calculus enables precise analysis and transformation of image. It is indispensable for understanding image structures, developing advanced processing algorithms. And what is the next step? Next step, I'll be exploring more of this and a new video will come out. But I hope not in a form of PPT. But thank you. I hope you had a great day.